In this video, I'm going to show the derivation of the transfer functions for these two interacting tanks to relate the liquid level of the second tank to the inlet flow rates of the first tank, Qi. Okay, for this process, Q1 is equals to H1 minus H2 over R1. Okay, it depends on both H1 and H2, not just H1 like the non-interacting tank. But for Q2, the formula is the same as the non-interacting tanks because it depends only on H2. Okay, this is R1, this is R2. Okay, so if we start with tank 1, we derive the mass balance. The final model would be A1 dH1 dt equals to Qi minus Q1. But then Q1, as we have the relations between H1 and H2 and R1 is Q1 minus H1 minus H2 over R1. And then we apply Laplace transform for both sides. First, you write this in deviation variable. So if you do, you have dH1. This one, after you minus this model with the steady state model, yeah, then you get H1 minus H2 over R1, and then you transform, use Laplace transform for both sides. You get A1 as H1 prime S equals to Qi minus H1 prime S over R1 plus H2 prime S over R1. And then if we bring H1 to one side and the rest at the other side, just simplifying this now, you have A1S plus 1 over R1 equals to Qi prime S plus H2 prime S over R1. And H1 prime S would be Qi prime S plus H2 prime H2 prime S over R1 over this. So this is one equation that is based on tank 1. And now if we do for tank 2, okay, the model would be A2 dH2 over dt equals to, it will be Q1 minus Q2, in minus out, right? Q1 minus Q2, and Q1 as we know is H1 minus H2 over R1, and Q2 is H2 over R2, right? And then we write this in deviation variables. After we subtract this model with the steady state model, then we get A2 dH2 prime dt equals to H1 R1 prime minus H2, and then we transform both sides and we get A2 S H2 prime S H1 prime S minus H2 prime S over R1 minus H2 prime S over R2. And then we group all the H2S together and leave H1S at one side, and we have A2S plus would be plus this one and this one H2S, right? So we have, plus 1 over R1 plus 1 over R2 equals to H1 prime S R1, and if you just want to write H1 prime S, we have H2 prime S, the whole thing times R1, right? Then we get A2 R1 S plus 1 over R1 times R1, we get 1 plus R1 over R2. So this is the second equation, and based on the first equation we have H1 prime S, and we also have H1 prime S here. So substitute equation 1 into equation 2, then we get, Qi prime S plus H2 prime S over R1 over A1S plus 1 over R1. 1 over R1, that is H1 prime S based on equation 1, and equals to H2 prime S A2 R1 S plus 1 plus R1 over R2. So that is the right hand side for equation 2. And now we just simplify this formula to get H2 prime S over Qi prime S. First, what I want to do is to multiply the right hand side with the denominator of the left hand side, so that the left hand side will just be this, only this, and the right hand side will multiply with the denominator lah. So we have A2 R1S plus 1 plus R1 over R2 multiply with the denominator of the left hand side. Okay, and then we just expand to multiply the two terms in bracket at the right hand side. You get H2 prime S. Okay, this is something that you need to be careful with the expansion. You have A1 A2 R1 S square, okay, plus A2 R1 cancel out, S plus A1S plus 1 over R1 plus A1 R1 R2 S plus R1 cancel out, 1 over R2. Okay, so this is after I expand this. Okay, these two terms I just expand, multiply the two terms, and we get this. Make sure correct, and then what next? We have H2S, 1 H2S here, so bring to the right hand side as well, so that we have only Qi prime S at left hand side and all the H2 prime S at one side. Then I have, just write back everything, A2S plus A1S plus A1 R1 R2S plus minus 1 over R1 from the left hand side. And what next? I want to multiply the equations left and right hand side with R2. Okay, if I multiply everything with everything right and left with R2. If I do, I get R2 Qi prime S equals to H2 prime S A1 A2 R1 R2, right, plus A2 R2 S plus A1 R2S plus R2 R1 plus A1 R1 S plus 1 minus R2 R1. Okay, now you see that you can cancel out this plus R2 over R1 minus R2 R1, and then the rest you simplify. You group the same coefficients for the same power of S. Then I have A1, A2, R1, R2, S square plus, okay, you have 3 terms with S to power 1, this 1, 2 and 3. If you group them, you have A2 R2 plus A1 R1 plus A2 R2 S, and then plus 1. And now if I define A1 R1 equals to tau 1, A2 R2 equals to tau 2, then I can rewrite this equation as R2 QI prime S equals to H2 prime S multiply with A1 R1 is tau 1, A2 R2 tau 2 S square plus A2 R2 tau 2 plus tau 1 plus A1 R2 S plus 1. And then if I want to write H2 prime S over QI prime S, it would be R2 over that whole thing in the bracket at the right hand side previously, which is T tau 1 tau 2 S square plus tau 1, I put tau 1 first, tau 1 plus tau 2 plus A1 R2 S plus 1. And from here we can identify lah, tau 1 tau 2 S tau square, and then tau 1 plus tau 2 plus A1 R2 is 2 zeta tau, and you can rewrite that transfer function as the standard form for second order transfer function, which is R2 over tau square S square plus 1.